the big question is, can security speed development? And with network policies, they forgot to take account of humans. So we're gonna think about people now. So first of all, yeah, it was the old title. It's fine, it's fine. So first of all, who am I? So originally, I started my career as a close-to-the-metal cybersecurity geek. I was working in the Israeli equivalent of the NSA. So that means I was doing reverse engineering, assembly, disassembly, C, C++, kernel development, that sort of thing. And then 8 years ago, something magical happened. I joined a cybersecurity startup and discovered I love what is now called platform engineering. One sec. That is building the golden path. I love building systems that take into account the human factor. I believe that empowering others to do more effective work is what it really means to be a 10x engineer, and this superpower is platform. When I don't play computer games, I'm the CTO and co-founder at Otterize, and I work better at night and play better at night. And I decided to have some fun with this talk. Spacebar isn't working, and I'm gonna tell you a story about an otter called Otis. He's an otter first and foremost, but he's also a platform engineer and a hipster animal, which you can tell by the hoodie. And he works at Otter Finance GmbH, and yes, I practice saying GmbH. So Otis has 3 others on his platform team, but they're responsible for building the platform for 100 other engineer others. Get it? So today, Otis has a meeting with Otis, who's the security engineer and red team leader. He's a red otter, as you can see, and you can laugh now, it's fine. The company has a PCI audit coming up, and Otis is meeting with Otis to ask, how can we remain compliant? Otis is suggesting that they roll out network policies, and the goal being every service will only access what it needs. So before we continue with our story, let's do a little refresher on what's a network policy. And yeah, it's big enough to see. So first of all, a network policy has a pod selector, like many other Kubernetes resources, that refers to the pods that the policy is going to apply to. Then there's the ingress section, which in this example has a namespace selector, meaning that it's going to allow, there's the ingress form section that has a namespace selector, meaning it's going to allow traffic from the namespace client pod. And it's going to allow from the pods with the label app client inside the client pod namespace. And finally, the bottom section says policy types, which is ingress or egress. Ingress meaning that the network policy is going to restrict access coming into the pod, and egress meaning it's going to restrict access traffic coming out of the pod. So back to being funny. To get started, Otis is focusing on ingress network policies. Ingress network policies, like I said, are basically an allow list of access to a particular service, and that is key to zero trust, blocking unintended access. So Otis now has to pick a service to start with, and he's decided to focus on the ledger, which at his company is a service that's responsible for making transfers of money. The API moves money around, obviously not something any service should have access to. And this is out of 100 other services. So to get started, Otis needs to create a network policy and label the ledger and its client. So our policy is gonna apply to the ledger, and it's gonna allow access from the client pod namespace and from the client pod. But on top of that, we also have to label the 2 pods. So we have to label the client, which is in the namespace client pod, and the ledger in the other namespace ledger pod. But they're actually in 2 separate Helm charts, in 2 separate Git repos, and owned by 2 separate teams. Now, the client team needs to deploy first. Otherwise, when the network policy is applied, all access will be blocked. So first, the client needs to deploy to get a new label, and only then can we deploy the network policy. Not too complicated. Otis is going to coordinate the 2 teams, ensure the PRs get merged in the right order and deployed in the right order. And I added highlighting, which I forgot. And that's it. We're done. End of talk. We can all go home and be happy. Or is it? On the left, you can see a punk platform engineer working in a bank. That's why they have money everywhere. And the team at Otter Banking Co. is calling to let us know the ledger is down. But we checked, and actually, the ledger seems to be healthy and up. So what's going on? Well, we acquired Otter Banking Co. last year, and their services are outside our cluster, but communicate with services inside the cluster. So it seems that their service can't connect to the ledger anymore because it was doing so through the ingress controller. It's fine for now, everything's burning down, but no problem, the ingress controller got blocked, and when we deployed the ledger, the ingress traffic started getting blocked. So let's fix it. We expand our network policy and add a couple more rules. Sorry, one more rule, allowing traffic from the ingress controller and its pod. We need to ensure that the labels on the ingress controller are never changed without coordinating this a matching change to this network policy. If there is ever a change to the labels without changing the network policy, then the ingress controller will start getting blocked. It's not that obvious, but Otis is going to document this as well, and people are going to figure it out. Oh no, now the monitoring team is talking to us. The Prometheus is getting blocked. So, okay, Otis is going to allow access from Prometheus to everything, but actually, you can't do that. If you added a network policy that allows access from Prometheus to everything else, what you'd end up doing is actually blocking everything except Prometheus, because the network policy only has Prometheus. So we have to only allow Prometheus once we already have a network policy in place that allows all other traffic. So let's add Prometheus to our network policy. And now it's already starting to get a bit complicated. We have the platform team who owns the ingress controller. We have the monitoring team who owns Prometheus, and the client team. And they all need to coordinate, make sure to never change their labels, deploy things in the right order. But okay, I mean, let's keep going. Oh crap. Now these guys with the red iPhones of doom, their service can't connect to the ledger. And we need to do the same thing, add their service to the network policy and coordinate the label. We forgot about them because we didn't have a way to see their traffic. And oh my, now we have 4 rules already and 5 teams that need to coordinate. And now the ledger has an unrelated bug, and they need to roll back the ledger. So they know the last known good version was 3 versions ago of the Helm chart, but if they just do a Helm rollback, they're also going to roll back the network policy for the mobile app team. So if they fix this incident by rolling back, they're going to cause another incident, which sucks. So it's not fine anymore, and he's angry. But it's okay. He's going to deal with it now and figure out what to do later. And Otis manually cherry picks the network policy changes and reverts everything else, and it takes 15 minutes longer, since that's how long their CI takes. And now this cute guy comes back again. He just wants to check on progress. And he also realized, like, how do we make sure that the network policy stays up to date over time? Developers change their code. How are we going to make sure that the network policy is current? And how do we know when access becomes unused and no longer necessary and can be removed? So Otis thinks about this, and he realizes the only way is to ask people, ask engineers, and there's 100 of them, and 3 in platform. And right now, it seems a bit too complicated to teach 100 people what he had just gone through, to make sure to never make any mistakes. So we can summarize the problems that Otis has encountered. You can breathe deeply. So the first problem was that you have to coordinate the deployment of the client and server. If the client is blocked, if the server deploys first, the client will get blocked. You must also allow ingress controller and monitoring traffic. And this actually has the unfortunate side effect of duplicating the declaration in an ingress resource, or if you use the Prometheus operator, a service monitor resource. You've basically already declared that there's going to be traffic coming into that pod from outside the cluster or from Prometheus. Why should you say that again in another resource? That's very anti-Kubernetes. So you got to make sure to do that, but also make sure not to do it before allowing all other traffic. And because we couldn't test the network policy changes, and we forgot the mobile banking app service, we ended up blocking the cute Otters with the red phones. Finally, when we wanted to roll back to fix the incident, we found out it can cause an incident, which is never where you want to be. You want to make it easy to always roll back so incidents are resolved quickly. And maintenance is hard and manual. How do you know when you can remove access? Because as we know from recent years, a lot of security incidents occur when unused access is abused because nobody knows it's still there, and an attacker eventually finds some old vulnerability in an old service. So why our network policy is hard? Basically matches the same issues we saw. They're all or nothing. When you add a network policy, everything that isn't on the network policy is blocked. You gotta get it right and get it right the first time or cause downtime. There's no dry run, test mode, or alerting. There's no tooling for testing if the network policy is gonna work. And trivial actions, or what used to be trivial actions, like deploying or rolling back, now require coordination. And this is happening because there's unclear ownership for network policies and the pod labels. Multiple teams have to coordinate to change one, and rolling back is no longer easy. And as you know, it's hard to maintain. Adding missing access or removing unused access is manual and error-prone. So that was hard. Nobody wants to do this. It's awful, but some people have to do this. So Otis thinks this doesn't seem designed to scale. Network policies are more like firewall rules and not rules for humans to use. They're there to be like IP tables or Cisco firewall rules. And they're definitely not designed for organizations with 50, 500, 1,000 engineers. They copy concepts from firewall rules where you have to do training that takes months, and now all of a sudden we're expecting 1,000 people to do them? I don't know. So is there another way? Can we make this simpler? Can we remember to take the humans into account so the 100 engineers can each do their part without teaching them all this network policy sorcery? So what's the ideal solution? Otis thinks about all the issues and he comes up with these principles. First, you have to apply the single responsibility principle. Each access resource, like a network policy, has to be independent. It shouldn't affect other services. It should have a clear single owner, and it should always be able to be rolled back safely. Each resource should be simple and statically analyzable. It should be possible for me as a human to just glance at the resource and know what's going to happen. When I look at a deployment resource and it says replicas 5, I know there are going to be 5 pods. When I look at the network policy and it says these labels, which are templated from another namespace, I have no idea if that's actually going to apply to any pod or too many pods or who. So it should be possible to just look at it and know who is going to get access. And as a side effect of that, it should also be possible to analyze it with a static analysis tool. And it should be testable. It should be possible to tell ahead of time, before actually making any changes, if existing traffic will be blocked. Finally, the process that manages adding missing or removing unused traffic should be automated and friendly to self-service. And it must not require any deep domain knowledge. So, how can we help this cute guy? Look at him, he's so happy. He looks again like he looked like in the beginning of the presentation when he thought he was gonna make a network policy with one rule and be done with it. So with Otterize, of course. Otterize implements a concept called IBAC, Intent-Based Access Control. So in that concept, each service declares the access that it needs, and this is kind of like an Android or iOS app manifest. In case you're not familiar, in Android, when you install an app on your phone, you never get a list of instructions to go into the settings and add permissions to access files or edit SE Linux settings so you can access the camera or the GPS. Instead, the app developer specified in a manifest that they need access to the file system, to the camera, to the GPS, and the operating system does the hard work of configuring that, and they always know it's gonna work. The developers always know. So this concept is implemented by the intents operator that creates network policies for you and labels pods. And now we're gonna do it demo. But before that, I have to change the display settings so you can see what I'm seeing. So can you do the magic thing where it shows my face in huge? Thank you. That is almost my face, thank you. Right. So, what do we have here? Sorry, this is the embarrassing part where we wait for the internet and pray that it works. But worry not, I took screenshots after what happened in the last talk. So if it doesn't work, we can switch to that. So I have a cluster. And in it, I have a couple of namespaces. Let me see how big this is. We are looking at the ledger prod namespace. And here we have a prod called ledger after our example. And we have another namespace that has two clients in it. We have the client and client Otter, and they're both connecting to the ledger. So how are we going to apply Otterize to all this without doing that mess with the network policies? So we're going to switch to another window that I'm going to need to make sure is big enough to show you what are client intents, which you might notice that IBAC, intents-based access control, is also named after client intents. Right, so what's in client intent is a specification of what access a particular service needs. Now, here we have the client service. The client service is declaring, I am the client service, and I am calling the ledger service in the ledger prod namespace. And this can also, in this case, we're just accessing another service in the same cluster, but we could also access a domain name in the internet, AWS IAM, databases, and a bunch of other things. And now, based on just this declaration, which lives in just one namespace and doesn't affect any pod directly, what we're going to see is the intents operator, which I've deployed in the cluster, is going to create a network policy and apply the correct labels to both the server and client. So let's have a look. So what I have here is the client intents for the client in the client prod namespace. And it's the intents I've showed you, the client going to the ledger. And now if we switch to the ledger service, to the ledger namespace, we're going to see a couple of network policies, actually, and not just one. One of them, called ledger access, is responsible for selecting on the ledger service itself and allowing access from the other namespace, from the client. So even though we declared the client intent in the client namespace, now a network policy in the ledger namespace has been created. If we roll back the client namespace, then this network policy will get updated. Now, the second network policy we're seeing is called external access to ledger, because actually the ledger has an ingress resource. So automatically, the ingress controller is being allowed, without us having to think about it or specify it. And it's as specific as the ingress resource itself, only allowing that specific port. So let's see what happens to the two clients. So client has client intents that allow it access, and there's a network policy. What we should be seeing is client being allowed and the other client being blocked. So client is making curl requests to the ledger, and the ledger is responding, I am the server, may I help you? And client Otter is actually doing the same thing, but getting timed out. So this was all in Kubernetes. This is all open source, by the way. And we can now look at the same thing in Otterize Cloud and see that if we look at the same cluster in Otterize Cloud, we can see that the client is connecting to the ledger and doing so successfully. We can also see the ingress controller doing so successfully, but client Otter is getting blocked. If we click on client Otter, then we get readably sized text. And you can see the client intents, and Otterize Cloud is telling us these are the intents that you need to have. And this specific intent was seen in discovered traffic. We've seen traffic for it, but it's not declared. And that is the reason that it's being blocked. Now, if we go back to the open source and say we want to fix that now. So is it big enough? Yes. And we run Otterize mapper export on the client prod namespace. So Otterize has multiple components. One of them, which I mentioned, is the intents operator. Another component is the network mapper, which captures traffic within your cluster and is able to map traffic in and out of the cluster, including to cloud providers. And that is the component that's feeding the network map that we just saw in the Otterize Cloud UI. But we can also consume that same data from the Otterize open source CLI directly from the network mapper, even on-prem without connecting to Otterize Cloud. And we can export the traffic in the client prod namespace. This is the part where the internet acts up. Yes. And we can see that we've auto-generated the client intents that we need for the traffic to work based on the existing traffic. So now I'm gonna do something crazy and just pipe it into kubectl. And first, we're gonna wait to see that it actually succeeds, because the internet, yay. And now, what we should be seeing momentarily is having this line change into green, which is gonna reflect that nothing is getting blocked anymore. And hopefully the internet connection is gonna cooperate. Yay, I'm blessed with good internet. So now it's green and nothing is getting blocked, and the line is still highlighted because that's the connection I clicked. If there are multiple connections, it would highlight just the one that you clicked. But now nothing is missing here. Now the thing is that if you did have the client intents, but actually the traffic was no longer seen, then Otterize Cloud would tell you, hey, you can actually consider removing this line because it's no longer in use, and that's how you do the maintenance. One more thing Otterize Cloud can do here is in this mode, we have the intents operator deployed in active mode, which means it's creating policies. But we can also deploy it in simulation mode, in which case it's not actually gonna create the policies, but the cloud is still going to do this simulation and tell us what would get blocked. And then we can decide to turn it on a per service, per namespace, or entire cluster basis once we see that we have all the green lines we want. So one last thing you should see is we didn't actually go back and see that client Otter is successful, but now they're both able to connect. And actually, none of the network policies have changed. None of the network policies have changed. Because what this network policy that gives you access to Ledger does is it just looks for this label, which is saying, I need access to the ledger. So when we apply the second client intent, the only thing that happened is that the client Otter pod was labeled with this label as well. So we saw a resource that is, applies the single responsibility principle, has a single team that owns it, can be rolled back and deployed at any time. We saw a way to test for network policies and make sure that nothing is gonna get blocked. And now we're gonna see a way to maintain these over time based on traffic. So obviously what you can do is you can use the CLI that I showed you to just generate the intents and diff them. You can always look at what you have in Git and run Otterize mapper export and compare the two. Or you can go manually into Otterize Cloud and look at what Otterize Cloud is saying. But another thing you can do is you can set up Otterize Cloud with GitHub or GitLab to have it automatically submit pull requests whenever these changes are needed. So for example, a developer pushes code to staging, and the client intent is missing because they're one of 1,000 developers, and they just didn't think about it, which is perfectly fine. And if you ask me, it's the goal for them not to think about it. And then Otterize is gonna see that that client intent is missing. If in staging you're in simulation mode, then Otterize Cloud is gonna be able to detect the missing client intent, submit the pull request, then the developer gets this very simple pull request and can just approve it. And done, everything will be green. And that's how you get to what it says on our website. It says 0 friction in development, 0 trust in production. you can end up with a workflow where developers don't have to think about access at all, not even opening Jira tickets, having meetings about it, they just write code. And Otterize Cloud does all the heavy lifting, and you still pass your audit, and you still get zero trust or whatever your goal is in production. So I am 4 minutes ahead of time. Excellent. I don't know how to stop the sharing. I guess this way. Ta-da! This is my screen. So, questions? Thank you.
Yeah, excellent. Let's go for a couple of questions before we break for a coffee or a tea or another beverage of your choice. Let's go with the first one. How can a service owner ensure that clients are allowed to use the service if clients can declare the policies themselves?
Right, so that's a common question we get. And actually, the client intents they go through the same SDLC process as your code. So your code gets, people write code, then it gets reviewed, and once it passes reviews and tests, it goes to production, and everybody is fine with that. So it turns out that most people are actually fine with applying that same process to the intents, which are not actually policies. They just specify what you need. But since intents are actually very simple to parse, you can use something like a Kyverno validation policy to apply additional criteria to whether they can be applied to the cluster or not. And that's what most of our customers do. And we're also building an approval flow into Otterize Cloud that will be able to specify certain rules for if something requires additional approval or not.
Alrighty, next one in line. Doesn't intents-based access control mean that an adversary might be able to gain lateral movement by declaring various intents?
Well, yes, but also it means only if they're also able to change your code. So client intents are a Kubernetes resource like any other, and you could say this about network policies as well. We're only as strong as the trust that's built into our systems. An adversary could also gain lateral movement by convincing someone in your HR team to add somebody to the platform team group in the email. So yes, but the tools to solve that are to make sure they are back for client intents, only allow your CI system or admins to make changes, and then you have to go through the normal approval processes.
Alrighty. Next one. How does a service accept or decline a connection intent from a client?
So the way to do that is using review processes on GitHub. Again, for most services, what our customers do is they actually want to, their goal is to know that the access is intentional, that is, that it's not an attacker, and not that they want to approve every single communication request. There are cases where that isn't the case. For example, a bank with a ledger service might want the financial security team to review all accesses to that service. But in the same bank, the team responsible for the logging service never wants to review requests to that service. So the tools to do that are applying additional restrictions with Kyverno, code owners on GitHub to just add additional reviewers to a specific file. And basically, Otterize is built to let you use existing tooling to review what is basically a YAML file. It's just simple enough that it's easy to parse.
Right, very good. I think 2 more questions. How much overhead is generated by Otterize Mapper?
Very little. We actually have customers who found the Otterize Network Mapper because they've used Cilium and other solutions and found out that they cause a lot of overhead. So the Network Mapper actually captures DNS traffic, TCP, SYN traffic that is very low relative to the total amount of traffic, and can run on around 200 milli-CPUs and about 500 megs per node.
Cool. Last one. Does Otterize have integrations to traditional firewall management systems? The idea is to manage also external connectivity through intents.
Not yet, because right now we're focused on cloud native. But yes, it's definitely on the roadmap, and it's going to happen.
That's a wonderful answer. Probably they want to hear that. All right, we're going to break for a coffee break. If you still want to have your question answered, let's join us in the front. And otherwise, I'll see you back here at 4 p.m.